If you go on a low-calorie diet, I don't care what it is, if it's a low-calorie diet, could be eating sawdust, whatever, you will lose weight because we're burning so many calories a day. And when you go on a low-calorie diet, it is going to cause weight loss. It turns out that certain foods make you hungry. And when you get hungry and you cannot control your appetite, you're going to gain weight because you're going to eat more calories. At the same time, those same foods activate this survival switch so that you are reducing your metabolism when you're at rest. And so you're burning less energy and you're hungry and eating more. The main food that triggers this biologic response is fructose. That's what our studies found.
Well, I'm so excited to connect with you, Dr. Johnson. Thank you for being open to coming on the podcast and talking about a topic that I really have a newfound appreciation for.
Thank you, Cynthia. It's really a great pleasure to be on your show.
So tell me how a nephrologist or a kidney doctor became so interested in uric acid. I'm sure you get asked this question often.
Well, the first thing is just to say that I'm a very curious person, extremely curious, and I tend to dive into things and keep at it. And it's probably like you. And so I'm a MD. I do see patients, and I have a very strong clinical practice. But I also have been doing medical research my whole career, and I became very interested in uric acid because it has a nice, interesting relationship with kidneys. The kidney excretes uric acid, but also can be a target for uric acid. And uric acid crystals can form in the kidney just like they do in the joints where it causes the disease gout. And so I was very interested in the role of uric acid in disease. And we were studying it. We found that it was important in high blood pressure, especially early on. And what we discovered was that in the early phases of hypertension, people tend to have a very high uric acid. And if you lower uric acid in people with early hypertension, you can control the blood pressure. And so that was a pretty exciting discovery that uric acid could have a role in blood pressure. And hypertension has been increasing in the country, just like obesity. And so I was wondering what might be driving up the uric acid as a mechanism for driving the increase in high blood pressure. And I was aware that sugar could raise uric acid, and it's not. So sugar is actually two different carbohydrates. It's glucose, which is that critical fuel in our blood, the critical carbohydrate fuel we use. And then there's another carbohydrate called fructose. And fructose is the sugar in fruits that makes fruit sweet. And when you combine fructose and glucose, you get a very delicious thing called sugar, table sugar. And you can also combine them, manufacturers will combine them to form this thing called high fructose corn syrup, which is also very liked by people. And so they add it to all these foods, including processed foods. And so there's a large amount of sugar that people are eating, and it's been increasing, and it correlates with a rise in uric acid. And so when I was studying uric acid and blood pressure, then I started studying sugar and blood pressure. And then we had this surprising finding that when we lowered uric acid in animals given sugar, that we could improve not just the blood pressure, which we expected, but also that we had effects on weight gain and fat and fatty liver and insulin resistance and other features of obesity. And that kind of changed my career. And I started really becoming a person who studied metabolism. And I dove into the biochemistry of how fructose works. And I expanded my research from lab rats to animals in the wild and in nature, and started studying evolution. And we resurrected extinct genes and started studying them. And we started looking at this from a very big picture viewpoint. And And then that led me to write this book right here. Nature wants us to be fat. And it's like an instinct. There's like a real desire to be able to have enough fat to survive. And there's biologic processes is driving it. And the insights from that have helped me figure out, what kind of, important factors on what's driving today's obesity and today's hypertension and diabetes. And it's also, by God, it's carried over to giving the insights into diseases like cancer and Alzheimer's disease, because it's sort of like we fell upon a very, very basic mechanism that has gone awry. As I say, it's gone awry in our current society because we're eating way too much sugar, and we're also producing too much fructose in our bodies too. So that's the short.
No, but it's such a fascinating discussion,
Yeah.
and listeners here are very metabolic health savvy. I think that, one thing I feel so very fortunate for is that I'm able to connect with clinicians and individuals like yourself that are really changing the narrative. I know that as someone who trained at a big research hospital in inner city Baltimore, you can imagine that because my whole background's in cardiology as an NP, a lot of the medications that I used to give my patients, as one example, would precipitate gouty episodes. And so there were specific medications that would address their high blood pressure, which would then give them what they affectionately referred to as gouch, as in gout and ouch. Gouch was a big problem for a lot of my patients. And so it really brings me back to thinking how differently we think about uric acid now, because I truly believe 20 years ago, we thought about uric acid, at least as a clinician, I thought about it as, I know when I prescribe this particular medication, what will likely happen is my patient will get a gouty episode, not making the interrelationship that there was the connection with the metabolic health piece. So I'm so grateful that your curiosity has brought you to, making these very important distinctions and continuing your research. Now, you kind of touched on the fact that obesity rates are escalating, and a lot of it is related to the dietary choices that are available to us and dietary choices that we are making. And so, can we at least start the conversation talking about the role of hibernation? Because I love how you kind of weave through your discussion talking about different animals and how animals in the wild their bodies will adapt to either food scarcity or temperature changes and turning on specific types of genes. I found this really interesting, the whole concept of triggering the survival response and how this actually impacts us as individuals.
Yes. So, it turns out that for years, most of us, including me, were really addressing diabetes and obesity by taking an animal with obesity and diabetes and trying to figure out what was going wrong. And, how is it that these diseases are occurring? What's the actual biologic pathways involved in diabetes? And so we're kind of working with the notion that these are diseases, these are bad conditions, and that what went wrong. And interestingly, in the wild, it's obesity is about what's going right. And what happens is animals will normally regulate their weight very well. If you take a squirrel and you give it extra food and force it to eat, you force feed it so it gains weight, and then you stop the force feeding, it will go back to its normal weight, and for that time of the year. Likewise, if you fast an animal, take away its food so it can't eat, and it will lose weight, and then you allow it to eat, it'll go right back to the weight it's supposed to be. Normally, animals regulate weight very well. There's some evidence humans used to do that better and also did that well. But what's happened is there's something that can trigger weight gain, and it's in animals. When it happens, it's usually desired. And what happens is the bear knows that winter is coming and there's not going to be much food around. And so if it just does its normal thing, it's going to suddenly be caught in the middle of winter with no food and starve. And the fear of starvation is a very significant thing. The birds that migrate long distance, some of them will migrate 10,000 kilometers nonstop. I mean, that's a huge distance. And they do it without food or water, and they just keep flying. And so how do they keep going? And so, we thought, wow, why don't we try to understand why these animals gain weight before these events? The bear will suddenly in the fall start gaining weight. And, what triggers that? What is it all about? And here obesity is a good thing. So, if we can understand why animals are triggering it and how they're triggering it, then we can go back to the human and then apply that knowledge to try to understand things. And it was incredibly insightful when we did that. The first thing was that we discovered that when an animal is preparing for hibernation, it doesn't just increase its fat. It doesn't just increase eating food and getting fat. It actually develops an orchestrated response. It's just this huge, it's like there's like 10 instruments in the orchestra that are all doing their special things. So the animal will it'll get hungry, even though it's eating a lot. So it loses its ability to control its appetite. And it gets thirsty. Even if it's drinking water, it'll stay thirsty. And it'll start foraging for food. It's an actual behavior. And it's really cool the way it does it, because it will increase, while it's foraging, it's spending energy, right? So it tries to overall reduce its energy, and it does that by reducing the energy while it's resting. So it reduces its metabolism while it's resting, so that it can conserve its energy for when it's looking for food. It's brilliant. Actually, it's brilliant. And then it will eat a lot of food, and it will preferentially store it as fat. So it will, when you eat, you make, you're eating calories, and the calories can be used. Really, there's three ways calories can go. They can be used as instant energy, which is our ATP, which we make. That allows me to talk to you and you to talk to me. So energy is key. That's the immediate energy, and that's the energy we feel. And the excess energy gets stored as fat. And that's also energy that can be tapped into when you're not eating any food, and you can break down the fat to make more ATP. And then you can also do a thing called uncoupling, where where the energy factories that are making the ATP, you kind of decrease their efficiency, and it leads to the generation of heat. And so you can uncouple the mitochondria to lose calories that way. But animals tend not to want to do that. What they want to do is they want to store energy or make energy. They don't really want to waste energy. So anyway, so when we started studying this, these animals, they get hungry, they get thirsty, they eat more, they're foraging, they start storing fat, and they also become insulin resistant, which I was taught that was like a bad thing, right? But actually, if you're an animal in the wild, insulin resistance is great because it helps preserve the glucose in your blood for the brain. When you get insulin resistant, just as a reminder, insulin is a hormone released from the pancreas that moves glucose into tissues, especially muscle. And it's really important to help deliver the glucose we eat into the tissues where they can be used. And the biggest site is the muscle. The brain uses a little bit of insulin for sure, but not a lot. And so there's many regions of the brain that don't use much insulin at all. So if you become insulin resistant, what it does is it reduces the glucose into the muscle, so there's more glucose allowed for the brain. And in a setting of starvation, that's a good thing. If you're fearing starvation or you're fearing food shortage, what you want to do is you want to preserve the glucose you have for the brain, because that's the key to survival, is to be able to navigate, to be able to think, to be able to respond when a predator is coming. And it isn't about just being strong. It's about understanding when danger's coming and what to do. So anyway, and then it raises blood pressure. And the goal isn't really to make you hypertensive. The goal is just to keep your blood pressure strong enough and your circulation strong enough so that in the setting of food shortage and starvation, you can maintain adequate blood pressure to hold, to be able to think and to keep your circulation strong. So it turns out this whole orchestration of events, even low-grade inflammation, is induced by this pathway, and that actually may help you fight infections and so forth. So it's a survival response. It's a survival response. The whole purpose of getting fat was to activate a process to protect us. It wasn't to, and actually, Cynthia, mild obesity, or, if you're overweight, it can be associated with survival in us. There's some studies that suggest, that if you have cancer, or if you have heart disease, or if you're old, I'm getting up there. And when that's true, you actually live longer if your BMI is like 27 versus 25. So being mildly overweight can be associated with an advantage, living longer. There's even one study that just suggests that for the population as a whole, it's probably better to have a BMI of 26. But I think most of us would not do not want to be overweight. And in a world where food is available all the time, it's not such a bad idea to keep your BMI around 20, 21. We know that the lower, that we want to be in a healthy range of weight, because that correlates so often with better blood pressure and lower cardiovascular risk and so forth. So although being a little overweight may be good if you have cancer and something, I still recommend that we shoot for a normal BMI. And so we should try to figure out why animals gain weight and what drives that process and how we can turn it around.
Well, I think you bring up such a good point, and I believe that we probably read the same study, because I think I was listening to a podcast when I was in the car, and my children were asking, their teenagers, what does a BMI of 27 look like? And so I was kind of talking about it, and I indicated to them, having been someone who spent 13 days in the hospital and lost 15 pounds, I can understand why it may be to your advantage if you have a little extra weight hanging around, because if you get a chronic disease or get an acute illness or spend time in the hospital, you have a little bit more reserves. But I agree with you in terms of metabolic health. We really need to be focused and conscientious about maintaining a healthy weight for each one of us. That might be a little bit different for each one of us, and making sure we're on as little amount of medication as possible. Now, when we're talking about kind of conventional theories for the obesity and pandemic, what are your thoughts on the concept of, CICO, this calories in, calories out model, which obviously I tend to align myself much more with the concepts, really looking at metabolic influence of the processed food industry. What are your thoughts on that? Because there's still a very fervent amount of the population that really wants to focus solely on calories versus the influence of food and hormonal regulation.
Well, so the first thing is, physics is true. So, but you are correct in what where you're headed, but physics is also true. So I'm going to try to explain this as best as I can. The first thing is, if you go on a low calorie diet, I don't care what it is. If it's a low calorie diet, could be eating sawdust, whatever, you will lose weight. You will lose weight because we're burning so many calories a day. And when you go on a low calorie diet, it is going to cause weight loss. So there is a role of calories and weight, okay, for sure. It's just, we actually, I have to say, I did some of the initial work to show that it was more than calories that drives obesity. In fact, I think, our group probably did the earliest work on this. So let me take you through it. It turns out that certain foods make you hungry. Okay. And when you get hungry and you cannot control your appetite, you're going to gain weight because you're going to eat more calories. At the same time, those same foods activate this survival switch so that you are reducing your metabolism when you're at rest. And so you're burning less energy and you're hungry and eating more. And that is going to be associated with weight gain. And you're going to eat more calories, and it's going to be how much calories you eat. It's going to dictate how much weight gain you're going to do. But for example, and high fat diets have a lot of calories because there's like 9 calories per gram. So if you've activated this biologic switch where you are hungry, you don't control your appetite, and you drop your energy, how much energy you're spending, now high fat foods are going to make you gain weight. Okay. So the main food that triggers this biologic response is fructose. That's what our studies found. And it found that that's why sugar makes you gain weight, because the fructose in the sugar affects your appetite, makes you hungry, decreases your resting energy metabolism. And now, once you've activated that switch, now when you eat French fries and fried foods, you're going to gain a lot of weight. You're going to gain weight with any food, but fat has 9 calories per gram, so it's just easier to get super fat with a high fat diet once you've activated the switch. So if I want to make an animal fat, I give it sugar to activate the switch because sugar has fructose, and then I give it a high fat diet. And when I do that combination, the animal gets huge. Okay. If I give the high sugar diet without the fat, they'll still gain weight, but it's slower because you have to eat a lot of carbs to get the calories that you would get with the fat. If I give fat alone, like if I give a lard diet alone, the animals won't gain weight. A high fat diet alone does not cause an animal to gain weight. The one sort of exception in the animal is butter, for some reason, causes a little bit of weight gain. I haven't figured that one out yet. But anyway, but really, if you give fructose, that triggers the biologic switch, and now you'll gain weight. So the very first thing to tell you is, yes, law of thermodynamics works. Now here's the special thing. You can also give fructose and prevent the animal from eating more. So they're hungry, but you now prevent them from eating what they want to eat. And guess what? First off, they'll still gain a little weight. So we did a study where we put them on a diet. These animals were on a diet. They were on caloric restriction. We had a control group and we had the fructose group or the sugar group. And even when they're on a diet, the animals gained a little weight because their resting energy metabolism was lower. So they were able to they could conserve, and they actually gained a little weight just with sugar alone. And the control animals lost weight because they did not drop their resting energy to the same degree. When you go on a diet, you do drop your energy metabolism a little bit. So they did a little bit too, but these guys on sugar dropped it more. Okay, but here's the catch. Even though they only gained a tiny bit of weight, all the animals given sugar still became diabetic. They all got insulin resistance and diabetes. They all got fatty liver. They all got hypertensive. They activated all these other processes that are bad. And I have personally taken care of people who are on diets, eating high sugar, and have gotten into trouble with fatty liver, with hypertension, and so forth, where we've been able to help them by reducing their sugar intake. So it turns out that there's two mechanisms for weight gain. The first thing is that, yes, weight gain is related to calories in and calories out, but it isn't just that you're eating more and exercising less. You're eating food. You have to eat foods that make you hungry, so you do eat more. But even if you control how much food you're eating, you'll still get all the metabolic effects associated with fructose if you're eating a lot of sugar or high fructose corn syrup.
It's interesting to me that when I started learning more about the influence of the processed food industry, so probably 10 years ago, I kind of did a deep dive into the role of high fructose corn syrup and kind
Oh,
of
yeah.
trending the data about the rates of obesity, and having trained in inner city Baltimore, where a lot of individuals were on public assistance and even like the WIC programs. And I attended a university where we did a lot of community outreach. And one of the things I used to always say to my professors was, most of what these people are eating and they're giving their infants and their children and their teenagers is setting them up for a lifetime of metabolic disease, because it's my understanding that liquid fructose and high fructose corn syrup is about the most destructive.
Poison.
Right. I was about to say, I don't even want to call it a food-like substance.
It's poison,
Poison.
honest to God.
Yeah, it's one of the worst things that you could ingest. And so I love that, you kind of brought that into relationship between weight gain and fructose consumption. And people that are listening, this is why it's important to read food labels, because there's a lot of high fructose corn syrup in packaged and processed foods. And it's oftentimes sneaky. The food manufacturers try to be so savvy. They try to do everything they can to disguise what type of sugar is in an item. There's all these now contrived, made up names. My kids and I used to play games when we were in the grocery store, and when they were younger, they'd say, well, it's dextrose, so it's not sugar. I was like, no, that's actually sugar. The many names of sugar.
Yeah.
So really
But
important to understand how that happens.
I want to follow up on what you just said. And just as you went back and looked in the 1970s when high fructose corn syrup was started being used, and how there was this dramatic increase in obesity with the onset of using high fructose corn syrup. I actually went back all the way through history. I was archaeology major in college, and so I actually went all the way back in time. But what I was really fascinated with was when sugar was first introduced back in the 500 BC. You can track obesity and diabetes by tracking the trade industry of sugar. And when sugar was brought into Egypt, that was the first time they saw diabetes, but it wasn't being seen in Spain at the same time because there was no sugar there, and so forth. And then initially, sugar was expensive, and it was the royalty and the people with power and the wealthy that were able to afford it. And so for a long time, obesity was very, very rare in indigenous peoples and so forth. And so it's really interesting. Like, early studies show that Native Americans and African Americans, there was almost no diabetes in 1890 if you were Black. There was like no diabetes. It was like no gout. It was like a case report. And same thing with Native Americans, and same thing with Pacific Islanders. There wasn't diabetes wasn't present before the introduction of sugar, and so it's incredible how there's been this role reversal where the disadvantaged peoples at one point were completely, there was no obesity and diabetes in these groups, and then suddenly, as sugar became inexpensive, we see this big reversal. And now, because they sell soft drinks for so little, it's like cheaper than water, drinking water. And so what's happening is that there are a lot of people drinking this as and so unfortunately now it's kind of a reversal. And And it's a disease that tends to hit the disadvantaged. And children and adolescents who are taking huge amounts of sugar. There's some studies that show that some adolescents are eating 25% of their diet. Yeah, 25% of their diet is added sugars. Unbelievable.
It really is. You know, when I lived in Northern Virginia, I was a co-president of a not a company. It was a group called Real Food for Kids, and
Oh,
we were
great.
trying really hard to reinvent what was considered to be a school lunch, because most of the school lunch was focused on my plate and was very carbohydrate focused, very little
Right.
protein, wrong types of fats, far too much sugar. And, you know, we were really proud of the work that we did within our school district. But I recognize that it's a privilege to be able to advocate that, you know, the local farmers are donating meat and you're getting fresh grown vegetables. That's not what the average impoverished child is able to consume. And sometimes, in many instances, the only time that they're getting food is when they go to school. And so I think that we really need to, as a country, we really need to reflect on you know, what we choose to value. And, you know, in a lot of ways, parents assume that if it's in a grocery store or if it's accessible, that it's healthy. And so I always think that it's important just to be fully transparent and say, you know, I have the ability to be able to make different choices for my family, but I recognize there are a lot of families that don't. And so just being conscientious about the amount of fructose that you are consuming, that in and of itself has a profound net impact on health and wellness. So one thing that's, you know, was really on my mind and I have so many notes, like when I read your book, I made so many notes, so many things. There's so many amazing facts. You absolutely need to go out and you know, look at this book. One thing that I found really interesting is when we were talking about calories as being the law of thermodynamics still relevant, when we were looking at data on how much more food we're consuming since the 1960s and the direct influence of some of it's behavioral, but obviously it is losing satiety cues, eating more in restaurants. But it was interesting, from between 1961 and 2013, we went from 2,900 calories to 3,600.
Yeah, absolutely. Let me talk about that for a second. But first, let me congratulate you on helping the children and being in a group that did that. I got involved with a group here called Living Closer Foundation, and we did a lot of work going to the schools and teaching the kids about sugar and getting them to look at labels and, you know, creating that, making a drink and showing that, you know, they would add a teaspoon of sugar and say, how does that taste? And then they would add like 10 teaspoons and the person would go, oh, horrible. And then they said, well, that's what's in a soft drink. And yeah, so congratulations to you on that. It's you know, education and trying to take this kind of information to the next generation is so important. Now, that your question about food, the fact that we're eating more, I have to tell you this study that was published in JAMA. So there was a study published in JAMA where they took they saw that these kids were, you know, a little bit overweight, and they were eating a lot of junk food and watching a lot of TV. Sound familiar? And so they decided to do a clinical study and take away the TV, and or they put monitors on the TV. But anyway, they were able to reduce the number of hours watching from something like 24 hours a week down to like 12 hours a week or something. And the theory was that when you do that, you're going to increase the activity and cause weight loss and the whole bit, because the idea was that the TV was the thing driving obesity. And then you know, when you're sitting in front of the TV, you're eating the junk food. And so if we could just decrease the time in front of the screen, it would have an effect. And the interesting thing is it didn't increase their activity at all, taking away the TV. Didn't have a big impact on any of this. So, you know, what we're learning is that as we activate this switch, we're becoming less active. Yes. And we're becoming hungry. So we eat more. And so when we go to the restaurants and people are giving us bigger plates of food, they're doing that because if they don't, you're going to leave hungry and you're not going to come back. And it's also true that there's a tremendous advertisement world trying to encourage us to go to movies and to go to watch TV shows, and they know how to attract our interest. And so there is, some behavioral things driving this too. But the bottom line is that there's a biology behind it. And, if you've activated the switch, you get hungry, you want to eat, you don't control your appetite. And, the big breakthrough was the discovery of this hormone called leptin. I mean, when this was discovered, I think it was I want to say it was in the 80s, but early 90s maybe. But Friedman was the one who really figured this out, that there's a hormone called leptin. And this hormone is released from our fat. And the hormone goes to our brain, signals to an area of the brain called the hypothalamus, and tells us when we're full. And so there are other, obviously, hormones involved in appetite too, but this is one of the big ones. And people who are overweight or obese tend not to respond to leptin. And so even though the leptin goes up after they eat, the brain is resistant to the signaling from leptin, and so they stay hungry. And that's been shown in humans. And if you give fructose to animals, they develop leptin resistance. We showed that when we were at the University of Florida, and they'll eat more. And the way you can prove it is you can take an animal and you can inject it with leptin. And if they're sensitive to leptin, they will immediately reduce their food intake over the next 12 hours. And if they don't reduce their food intake at all, it means that they are resistant to leptin and they're still hungry. So you can actually do these kinds of tests. And fructose caused leptin resistance. And once you become leptin resistant, then when you give high fat diet, they'll gain weight very quickly. And if they that's why a low carb diet. So when if you put them on a fructose restriction, the leptin resistance will recover over a period of time. And when we did it, it only took about 2 or 3 weeks on a low carb diet, and maybe even 2 weeks, and you became leptin sensitive again. And so this is why when you're on a low carb diet, you're on a high fat diet, but you're not gaining weight because you are not leptin resistant. And so it's a fantastic, now you can eat that high fat diet and you're not really going to gain weight. Of course, a lot of us, it's not the fat we like, it's the carbs we like. And so that's the struggle of a low carb diet, is that people love sugar and they love high glycemic carbs.
It's definitely a challenge. And I find leptin is probably one of my favorite hormones to actually talk about, because it explains for a lot of individuals. And I seem to work solely with women. It seems to explain why they eat a meal and then they're still hungry. And then once they understand that there's a hormonal dysregulation, it explains quite a bit. And it's so validating because they've been told all you have to do is control calories. And we explain, yes, potentially. However, what we also need to focus in on is that if these hormones aren't properly balanced, our appetite we're never going to be satiated, and we're going to keep looking for food, and we're not going to be looking for broccoli. We're going to look for chips and ice cream and chocolate and, a dirty cupcake and whatever else we can get our hands on.
You're exactly right. The other thing which we definitely need to talk about is this issue that it isn't just the fructose we eat, that the body can make fructose. And this was such a disappointment for me. I have to tell you that it was a disappointment for me. I knew that there was a problem with fructose story, because there are animals that gain fat that are not eating a lot of a ton of fruit, for example. And so, and likewise, some people will tell you that, they know that bread or potatoes make them fat. And so, I knew that, and those don't contain fructose so much. And so I knew that there was something more. But so in some respects, it was great to figure out how it was working. But it was a disappointment because I was hoping to just incriminate sugar and high fructose corn syrup, but those aren't the only foods that cause obesity.
Well, I think it's important to talk, and listeners are familiar with the terminology of mitochondria, and that's the powerhouses of our cells. But if we're going to kind of lean into this fructose discussion, there's probably value in at least touching on what's happening with the ATP or the energy that is sparked in the cell that's impacted in a way that generates this other pathway.
Yeah, thank you for bringing that up. So just to begin with, we know that energy is really what constitutes life. Having energy is what makes us who we are. And so it's probably not a big surprise to know that it's critical for an organism to have enough energy. And so we talked about energy as being stored energy and ATP. But what the animal senses is its ATP levels. So if its ATP levels go low, it seems to trigger the fear of starvation. And if you starve an animal, its ATP levels will go low. Because it will start using the fat to make up the ATP. But when the fat goes away and you're really starving, then the ATP levels fall and it becomes like a crisis. So somehow nature figured out that if they want you to gain weight, why not trick the body into thinking its energy levels are low? And if I can trick the body into thinking its energy levels are low, it's going to start eating more. It's going to start trying to put on fat. It will just be the natural response, the instinctual response. And what fructose does is it drops the ATP in the cell. And it does that by shifting the calories towards fat, which is stored ATP, but which the body can't sense. So when the ATP levels fall inside the cell, it's like an alarm signal. And almost all nutrients we eat, almost every food we eat, tries to keep the ATP at a high level. And only one nutrient that I'm aware of, only one, drops the ATP level. Alcohol does a little bit, but that turns out it may be through fructose, believe it or not. So, but anyway, we'll get there in a bit. But when you eat fructose, it drops the ATP in the cell, and it signals an alarm and says, oh my God, your energy levels are falling. Time to start eating more, foraging for food, becoming insulin resistant, start storing fat, start storing all these things, raise your blood pressure. It's the trigger, and it does it by dropping the ATP. Now, the way it drops the ATP is totally cool. First, it consumes some ATP when the fructose is being metabolized. So fructose is metabolized so fast, and whenever you metabolize anything, you use some energy. You use some energy to digest food, to absorb food, to break down food. But there's always these very careful feedback systems to keep ATP levels normal, but not with fructose. So the first thing fructose does is the more fructose you see, the more rapid the ATP falls. And so that's why soft drinks are really bad, because you get a large dose in a short time. So the concentration that hits your liver is high. And so boom, the ATP levels fall, and that triggers an alarm. Now, it isn't just that fall in ATP, because if it was, that only lasts, a few minutes, maybe an hour. And so what happens is once the ATP is consumed, the consumption of ATP generates a substance called AMP, which is then made back to ATP. But now this fructose activates an enzyme that sweeps away the AMP so that the AMP can't be made back to ATP. And it gets even continues on. That AMP is then broken down to the substance uric acid, which is how I got involved in this whole story. And the uric acid stuns the mitochondria, those energy factories, and reduces the energy produced from the mitochondria by blocking things in the Krebs cycle and then beta fatty acid oxidation and other things. Basically, it blocks the generation of ATP from the mitochondria. So that keeps the ATP levels low. And then there's this kind of primitive system that starts to take over that doesn't require oxygen called glycolysis. And that's good too. And interesting, by suppressing the mitochondria, it's actually helping the organism, because one way you can get into trouble is if you don't have enough oxygen. And the mitochondria is where you use that oxygen to make energy. So if you have an energy crisis, this is a system that also protects you in a low oxygen state. So animals that are burrowing in the ground, that get into, these like naked mole rat that lives in these deep burrows in Africa where there's like no oxygen down there, they make fructose. They're making fructose to help reduce their mitochondrial function and to increase glycolysis so that they can live off ATP without needing oxygen. So it's a survival mechanism, suppressing the mitochondria, stimulating this. And then there's also, it turns out that there's more ability to regenerate energy from a thing called AMP kinase, and there's another mechanism called the salvage pathway, and those get inhibited too. And so what happens is it consumes ATP, it reduces the production of ATP, and it blocks the salvage pathways that allow the recovery of ATP. And so the result is that ATP levels fall and they get somewhat low in the cell, and that's what drives the switch. And guess what low ATP levels do? It makes you tired. It doesn't give you the energy you want. And initially, when this happens, you do recover after a number of hours. So what will happen is you'll keep eating, making more ATP and fat until finally you reconstitute your ATP levels, but at the expense of getting fatter. And so it's not a good system if you're chronically activating it. And then the other problem is if you're chronically activating this continued suppression of the mitochondria through this oxidative stress that the uric acid does, leads to a reduction in the mitochondria over time. And that's really dangerous, because as we reduce our mitochondria, that's really what we start seeing with aging. That's what we see when we kind of get locked into our weight, where you've now gained weight and it's not so easy to lose it. Or if you do lose it, you go right back. And that is often associated with, suppressed mitochondrial function, and sometimes actually reduction in mitochondria. And so in that case, you've got to do things to not only do you have to turn off the switch, but now we have to stimulate the regrowth of those mitochondria so you can be young again, so you can have that energy, so you can eat a regular meal and not worry about gaining weight. And so, what's fantastic is that, understanding the biology allows us to see the solutions. And it's actually possible to cure obesity, I think. And it's going to be possible to really help people a lot, with knowledge of this pathway and how it works. And most of the things that work today, that like your intermittent fasting and low carb diets, these are wonderful approaches. And we can understand the benefits of these approaches by, through understanding the science. So by understanding the science, suddenly we go, oh, wow, that's why low carb diets work. Oh, that's why intermittent fasting is more than just reducing calories. It's allowing the mitochondria to recover. And you can show that, if you go on a low carb diet, or if you do intermittent fasting, you can show that allows the mitochondria to start to recover and they start to grow again. And exercise can do some of the same things, this zone 2 exercise. So what's wonderful is that when we were kind of working through the science, the biology, we go, aha, yes, that's why this works. That's why the Atkins diet works. That's why intermittent fasting works. That's why. And then we had some surprises too, like the dehydration story, which actually was not well known. And that may be one of the newest breakthroughs that's in the, that in the book distinguishes it from a lot of other books, is the importance of dehydration in obesity. But we can talk about that, I guess.
No, and I have to tell you that, as you were talking about dysfunctional mitochondria, and one of my favorite benefits of fasting is autophagy and mitophagy, and being able to get rid of these disease disordered cells. And so something listeners are definitely, they can make that association, and how critically important. Like, we don't do fasting just to change body composition or lose weight. We do fasting for all these, I always say, behind, kind of underneath the hood, the things that may not be visible to us that are going on within the body that help to support the body. I do want to talk about dehydration. In fact, this is like one of my, it completely blew my mind. So let's talk about what dehydration is. Why is it important to these pathways? Why is it relevant? And I'm literally, as I'm sitting here, I'm thinking to myself, I've been doing a lot of talking today. I can already tell I'm clinically dehydrated. And in the back of my mind, after reading your book, I think differently about dehydration and why it's so significant.
Yeah. Well, I'm a kidney specialist. So when I was in training, I was told that there was a myth that goes around that says that, you need to drink 8 glasses of water a day to stay thin. And that was a myth, because if you get dehydrated, the kidneys do the work for you. And since I'm a kidney specialist, I should know that. And so this is, in fact, that myth came up in a New York Times op-ed thing this last fall, saying that actually saying that drinking 8 glasses of water a day is a myth, but it's not. It's based on hard science. I have a paper in a very top journal showing how it works. And let me explain, because hydration is a major key to health. And all those people who are running around with the water bottles, and many of them are thin, as you probably know, there's probably a reason that correlates. So let me just take you through it. Interesting, this came back from our studies in nature. Yeah. So we were studying obesity in nature, and we had this kind of big insight that fat isn't just a source of calories. Fat is a source of water. Now, I know you're going to say, what? Yeah, fat, you can't mix water with fat, right? There's no water in fat. But when you burn fat, you produce carbon dioxide and water. And animals know this. Biology knows this. We've known this, but we don't really talk about it. But like the camel has a hump of fat, and when it needs water in the desert, it will break down the fat, not for the calories. It probably uses the calories too, but for the water. And a lot of animals in the desert will have fat like in their tails. They don't want it on their body because that will cause insulation, make their temperature go up. So they put it like on a hump, or they love to put it in their tail. So there's this lemur that has a fat tail called the fat-tailed lemur. It's the only primate that hibernates, and it does so actually in the summer. So it's really called estivation when you do it that way. But what it does is it finds a little hollow in a tree, and it just goes in there and it sleeps for like 5 months and uses the fat to provide water, because it tries to survive the dry season when there's very little water around. It's using it mainly for water, not for energy. It uses it for energy too. And it turns out the hibernating bears, they're not drinking water during the hibernation. They're getting their water from the fat. And it turns out that, you're a long distance migrating bird. Yeah, you're using the fat to provide you the energy. It's giving you the water too. So it turns out that fat is a source of water. That was a big insight, because when we knew that animals would start to eat and put on weight and fat when there was going to be no calories around, but we started realizing that they might do the same thing when there's no water around. that they have to activate this switch to store fat to protect them. And so that we said, aha, maybe dehydration can be a stimulus. And when we, and you know, this gets back to the fact that the body can make fructose. And, you know, we had discovered that high glycemic carbs can make fructose. And that's why bread and rice and potatoes were so bad. It wasn't just the sugar we were eating, but when you eat those substances, your body can make fructose. And it does so through a pathway called the polyol pathway. And the polyol pathway was known to be activated by dehydration. Ha! So now we got a story, because if you get dehydrated, then you activate this polyol pathway, then you'll make fructose to help you store fat as a source, another source of water. So at that point, we realized that fructose can be produced in the dehydrated state. And we looked at people who were overweight, and it was striking how common dehydration is if you're overweight. I mean, most people who are overweight or obese are not drinking enough water. They have higher markers of dehydration, such as serum sodium, or the salt concentration in their blood tends to be high. There's other markers. You can do a thing called bioimpedance and measure the water inside the cell and so forth. And it turns out that people who are dehydrated are, people who are overweight or obese are much more likely to be dehydrated. So it turns out that dehydration is a major mechanism for stimulating this fructose production in your body. Now, the question is it just, you know, when we talk about dehydration, I usually think of the person who's out in the sun and they're sweating a lot and they're exercising too much, and they get dehydrated, or maybe they have diarrhea. So it's like losing water. But there's a trick in nature to try to make you dehydrated, and where you don't have to lose water to get dehydrated. So if you want to gain water to protect yourself, you don't want to get dehydrated by losing water to stimulate fructose. You want to keep gaining water to help you protect you during the time when you're out in the desert. And the best way is to eat salty food, because when you eat salty food, you're not losing water, but you're gaining salt, and the salt goes into the blood, and the salt concentration goes up, and that makes you feel dehydrated. You get thirsty, so you want to drink more water. So that's going to be one way to drink more water. But if you're also stimulates you to become hungry and activate the switch, it's actually helping you store fat as well. And so guess what? People who are overweight and obese tend to eat a lot of salty foods. And salt is very, very common in processed foods. And if you give salt to an animal, you know, it takes a longer time, but it activates that polyol pathway, and then the animals become super fat and they become diabetic. So salt turns out to be a slow way of becoming obese. Sugars, you know, if you're a rat, a laboratory rat, and you take sugar, you're going to become fat and insulin resistant in a couple months. If you give salt, it takes like 4 or 5 months, but you're going to get fat. And the way the salt works is it raises the salt concentration in the blood, activates the polyol pathway, and that helps convert carbs to fructose. So it does require carbs. It does require carbs to be present. And so, you know, if you're on a low carb diet and you just ate salt, you would activate the enzyme, but if there's not a lot of glucose around, you're not going to get fat from that. So the high salt diet is really a way to help convert carbs to fructose. And so that's an important thing to know. But anyway, so it turns out that, you know, animals in the wild, they find salt licks. No one really knew why they like salt. It turns out some experimental studies suggest that they use the salt to help them put on fat and to get bigger. And then actually in some places in the world, animals are given salt to try to encourage weight gain.
That's really fascinating. So, one of the questions that came up while I was reading the book is, are we talking solely about iodized salt that's in the processed foods, or are we talking also about high quality Himalayan salt or Celtic salt? Like, because I'm in my, of course, in the back of my brain, I'm thinking, well, I don't really eat a lot of processed foods, but does that also mean my regular salt, my high quality salt that I use on my food, especially like meat, that brings out the flavors? Because I'm sure there are a lot of listeners that are thinking exactly the same thing.
Yeah. So first off, it turns out that it's sodium chloride, and if it's other types of salts, it's not the same. It has to be sodium chloride. So that's the first thing. The second thing is really related to it's all about the how much you're taking, you know. So in processed foods, they can put huge amounts of salt. If you make a homemade risotto, you'll probably use less than a teaspoon of salt. But if you buy it, it can have five times the amount of salt. So it's all about the dose. It's sort of like fructose. It's all about the dose and how quickly you eat it. Soups can be dangerous because soups can really contain a lot of salt without you really realizing it. And we actually did a study in people where we took soup and made it salty purposefully and gave it to people with or without water. And if you took water with the salt, so that the salt concentration did not go up in your blood. I mean, you took water with the soup, I'm sorry. So that the salt concentration didn't go up in your blood, we could block the activation of the switch. Blood pressure didn't go up and so forth. But if we didn't give the water, then you could activate the switch with the salty soup. So getting back to your question, I'm not sure what Himalayan salt is. And there's no question that salt enhances food in so many ways, but just be careful with how much you use and drink water with it. So here's an incredible thing. If you drink a glass of water before you eat the salt, you're going to dilute your serum sodium down a little bit. And then if you bring it back up to normal with the salty food, nothing's going to happen. On the other hand, if you eat salty food first and make the salt concentration go up in your blood, you're going to activate the switch, and then you're going to have to turn it off by drinking water. And you can turn it off by drinking water. We did that in our animals. So you can, if you give enough water, you can block sugar from causing obesity. So, water is just a powerful thing. But I do want everyone to know that you can overdo it with water. We don't want you to be drinking huge amounts of water because you can become intoxicated with water and end up in an emergency room. Don't do this and say, well, Dr. Johnson told me I should drink a lot of water. Drink 6 to 8 glasses a day. That is a good number. Bring your urine output up to like 3 liters a day if you want to measure, how much you're producing. And that's associated with good health. If you're running in a marathon, just drink to thirst, because marathons can trigger water retention. And if you just had surgery, I know you had surgery once, you right in the post-op period, be very careful about water because people tend to retain water easily then. And if you do those rules, you'll be in great shape. And if you have any concerns, talk to your doctor, because if you have heart failure, for example, you might retain water as well. So there's some warnings to it, but in general, the vast majority of the population are not drinking enough water. And if you could drink more water, that alone would have a major effect on blocking obesity. In fact, we discovered that the hormone vasopressin, there's a hormone that goes up in our blood when we're dehydrated. That hormone actually is a fat hormone. So when that hormone concentrates the urine to help prevent water loss, so when you get dehydrated and your urine gets really concentrated and yellow, that's because that hormone's working. And that hormone's working in the kidney to prevent you from losing water. It wants you to hold on to water. So guess what? It also stimulates fat, because that's another way to store water. So you can measure vasopressin in the blood. It probably is a great marker for, it is a great marker for predicting if you're going to become obese or diabetic. The blood test is called a copeptin test. And it's a great way to predict how if you're drinking enough water. But a simple way is just to drink enough water so that your urine isn't translucent and pure like water. You want just the tiniest yellow color to it. Very, very, very light yellow, very, very light yellow. And you want to make about 3 liters of water a day. That would be of urine a day. That's what you would keep you very well hydrated.
And I think it's interesting because hydration is considered to be kind of this benign entity. I tell listeners all the time, I have about a 60-ounce glass container, and that's how I monitor my water intake during the day. And I can tell by the end of the day if I haven't hydrated enough. And it's so, so important. It's so foundational to our health. And certainly, this is just yet another incentive to make sure that we are consuming enough hydration. Now, I want to touch on 2 more subjects, and I know we're getting close to the end of our discussion. Let's talk a little bit about alcohol, and then I want to hear more about the switch diet so that, we'll round out this very vibrant conversation talking about the things you can do. But because alcohol, especially over the past 2 years, I think is particularly relevant. I think most individuals that I talk to were probably consuming more alcohol than usual given the past 2 years. I'll just put it that way, without specifically relating it to a particular virus or a pandemic. So let's talk about what happens in the body when we consume alcohol and why it's very common, or at least clinically, it was very common for me to see that a lot of alcoholics were also sugar addicts. I have a family member who's an alcoholic, and this individual essentially consumes fruit all day long. That's the large basis of their diet. That's really what they crave and what they want. But there's actually some science behind all of this.
Yes, there is. So, alcohol, there's frequently alcohol is given with sugar. A lot of these hard drinks, like margaritas and pina coladas and so forth, involve mixing hard liquor with sugar. And there's a reason, because that the combination seems to work together in the brain. Sugar stimulates like craving and dopamine, and alcohol does as well. And so they're both kind of working together. And it's very easy to become addicted to hard liquor in particular. Beer and wine also have a fair amount of alcohol with it. And it turns out that they can also be involved in this whole pathway that we're going to talk about. So, but the worst is the combination of alcohol and sugar. So it's been known for a long time that people who like alcohol often like sugar, and people who like sugar tend to like alcohol. So there's lots of papers on this. The big breakthrough came, with this discovery that the body can make fructose, because we'd known about it, but we never thought it was that important. But now there are papers out there. A lot of it came from my group, but there's another group as well that identified 2 other groups that when you drink alcohol, the alcohol activates the enzyme that converts carbs to fructose. So again, it activates the polyol pathway. It's not the alcohol that becomes fructose. You drink alcohol, you make fructose, but you're making fructose from carbs. So when you're in the bar and you're drinking a drink, and then you eat those pretzels, the alcohol is helping your body turn those pretzels into sugar in your body. And so, and the salt also does. So salt and alcohol are working together. So when we gave alcohol to animals, first off, it's known that alcohol can cause liver disease. And any doctor knows this, that alcohol can cause a disease called cirrhosis, and that's often associated with fatty liver. And so they get fatty liver, and then they get cirrhosis, and then it can cause liver failure and death. And when we gave alcohol to animals, we found that they got fatty liver and liver disease, but they were making fructose, and we knew that fructose could cause fatty liver. So we asked the question, could the alcohol be causing liver disease through fructose? And what we did is we had these mice that could metabolize alcohol fine, but they can't metabolize fructose. And we gave them the alcohol, and we found that that they did not get fatty liver. And so it turns out that this has been discovered by 2 other groups as well, that the liver disease from alcohol is from sugar. It's from the fructose that the alcohol is triggering the production of. It's unbelievable. So now when I go and round at the hospital and I see patients with alcohol liver disease, I find that almost always they have sugar or soft drinks in their room because when they can't drink alcohol, they want to drink sugar. But the sugar water and soft drinks are also bad for the liver. So you need to actually tell them that and try to have them avoid that. Now, the other side of the coin is that the craving of sugar and the craving of alcohol are linked. And, we know that we have taste receptors for sugar, sweet receptors. But did you know that if you knock out the sweet receptors so you can't taste sweet, you still will love sugar? So animals that cannot taste sugar will still pick it out and become fat from the sugar. So the sweet receptors help you find foods that have sugar in it, but the addiction is not driven by the sugar taste. Interestingly, artificial sugars help, activate the sweet receptors on the tongue too, cause a little dopamine response. There's a little pleasure there. But if you knock out the sweet receptor, the animal doesn't care for artificial sweeteners anymore. And so it's the fructose. The fructose is causing craving through a mechanism that doesn't involve the taste. And it's probably through its metabolism and the fact that it lowers the energy levels, and that makes you crave. And we believe that that's likely the mechanism. So when we block the metabolism of fructose, we can block the craving of sugar. So if I take an animal and I prevent that ATP level from falling, suddenly it doesn't care about sugar anymore. It still likes glucose a little bit, but basically it doesn't care for fructose anymore. The fructose only is working by dropping the energy, and then you don't really care for it. Now, alcohol for years has been also reported to drop ATP levels in cells, and we think it's because it's being converted to fructose. And when we took animals that could not metabolize fructose and gave them alcohol, they showed a reduced intake of alcohol. They still liked alcohol, but they took about half or less, maybe even a third or a fourth of the amount. And so this led the National Institute of Health to give us funding to try to develop inhibitors to block fructose metabolism as a new treatment for alcoholism. And, that I spend a lot of my time every day working on trying to develop inhibitors to help people who have alcoholism. And I'm working not on blocking alcohol, I'm working on blocking fructose as my means to prevent that. Now I have to give a statement that we haven't published the paper on this yet. But it's coming. And I'm comfortable talking about it, though.
It's really fascinating. I think because I grew up with an alcoholic parent, I understand alcoholism, probably both clinically and also personally. And so I'm so grateful that you're doing this kind of research to help alcoholics and their families. Now, I want to be respectful of your time, and I want to make sure that we touch on the switch diet, so that for people that are listening, that are trying to figure out what should I be doing or what should I not be doing. Let's spend a little bit of time talking about the switch diet, what it is, what it incorporates, breaking down the macros, which I think is really important.
Okay. So there's really two aspects to my prescription for staying healthy. One is how to prevent activating the switch. And that pretty much is what we call the switch diet. So it's, because if you don't want to get fat or diabetic, you want to be able to understand how to not activate the switch, or if you're going to do it, it's sort of like a dimmer switch. So, it's not that you're going to have it off the whole time. It's just that you're going to try to not be activating it a lot. And then there's a second approach, which is, let's say you're already overweight and your mitochondria are suppressed. How do you get back to a healthy weight? So there are really two different prescriptions. But when I talk about the switch diet, it's really, how to stay healthy. And, and the biggest thing is obviously to figure out how to reduce your exposure to fructose. And so the obvious one is soft drinks are off, liquid sugar, fruit juice, soft drinks, power energy drinks, power drinks. These are like the worst. You do not want liquid sugar because the concentration is really high, and it activates that switch big time. Obviously, trying to minimize cakes and things like that. Sugary foods, and reading labels. That's really important. Jams and jellies and sweetened yogurts and barbecue sauces. These kinds of things are obviously high in sugar. Processed foods are often high in sugar. So you have to read labels. And so that's important. Now, interestingly, natural fruits have fructose in them, and animals will become obese by eating huge numbers of them. So orangutan will eat like 100 of these large fruits. They gorge all day long on them. We don't gorge all day long on fruits, except maybe your friend. And so most fruits have like between 3 and 8 grams of fructose. And there's a shield. The intestine shields you. The first 5 grams or so is inactivated in the intestines. So like the fructose in vegetables, don't worry about them. Don't even think about them. The fructose in natural fruit, one fruit is going to be primarily inactivated. Yeah, there's some fruits that have a lot of sugar in them. Figs, for example, be careful with figs and dates. Be careful with dried fruits. But a lot of fruits, they have fiber, they have vitamin C, they have all these things that kind of counter the effects of fructose. And so, the intestine shields the first 5 grams. So natural fruits are okay. You don't want to eat a huge number. You don't want to eat a bowl of grapes in one setting, but basically I go into this in my diet. It turns out that high glycemic carbs are the other big bad guy, because they can get converted to fructose in the body. So that's rice, potatoes, chips, cereal, bread, the things we love. And so, I try to give good guidance on this. And again, part of it is how you do it. So for example, if you have a piece of bread and you put an avocado on it, that will actually decrease the glycemic index. So I have a continuous glucose monitor. If I eat a piece of bread, my glucose goes up to 130, and that triggers the production of fructose. Okay, not good. 130, 140. If I put some avocado on that piece of bread, my glucose goes up to like 105, 110. It's not going to activate. So if you can keep your glucose to like 120, 110 following a meal, or lower, you're not going to convert. Or if you're going to convert any fructose, it's going to be pretty small. So, high glycemic foods you got to watch. Drinking a lot of water. We already talked about that. Try not to eat really salty foods. If you get thirsty, you've activated the switch. Meats. So it turns out that you can also activate the switch with certain types of umami foods. So umami is the third taste that we like. So there's sweet and salt. We like those for a reason, because it was to help us identify foods that could activate the switch. Umami turns out to be a receptor for uric acid, really. It's basically a taste for foods that are high, that will increase your uric acid levels. And it's all part of that same switch. Remember, fructose gets converted to uric acid. So umami foods can cause obesity if you eat a lot of them. And the good news is we usually just use umami as more like a flavoring. We don't really eat grams and grams of glutamate and umami foods. There's some exceptions. The big one is beer. And beer is it's like a soft drink. It's not the alcohol. The alcohol is bad enough. The alcohol will activate fructose production, but the yeast has the brewer's yeast in the beer is what is really responsible for this rich umami that can activate the switch. So it turns out that of all the umami foods, it's beer that you have to be most careful of. And that beer gut and the beer, rise in blood pressure and triglycerides and fatty liver, it's all part of the same switch. Beer is like a soft drink. I hate to tell you that, because I know so many people love beer. If you're going to drink it, sip it, try, remember again, it's about the concentration. So if you have to have a soft drink, drink it over the longest period of time you can, mix it with water, and and same thing with beer. It's not that you can't drink a beer. You just have to drink it slowly. Don't drink it fast. And then in terms of meats, processed red meats turned out to have a lot more umami, glutamate release and stuff, because of the way the meat's prepared. And processed red meat is associated with diabetes, is associated with obesity, and probably for that reason. Unprocessed red meat, poultry, they're probably fish. For the most part, they're really good. You can be a vegan and do well on this diet. You can be a carnivore and you can probably do well on this diet too. So it's about the type of foods you eat within a group. So there's good proteins and bad proteins. There's good fats and bad fats. Monounsaturated fats are good. Omega-3 fatty acid rich foods are good. And so what's wonderful is it sort of fits what people are discovering clinically. And then there's a huge benefit of intermittent fasting. If you want to lose weight, a huge benefit. The keto diet is a great thing. I'm a little worried about being on the keto diet chronically. I don't think that ketones are really enough long-term for people. But I certainly met people who are doing well on it. But I'm a little, I haven't studied it well enough to be certain, but I am a little nervous about doing the keto diet for a long time. So I would do it for like a month or 2 months, but then I would try a little bit more balance. So that's sort of the big story. I actually am a fan of dairy. I understand that a lot of people have believed that casein is not good, this dairy protein, but I haven't really studied it. But from the literature, I kind of like milk-based products. If you're not lactose intolerant, based upon my reading.
Well, that's so helpful and certainly gives people a perspective to switch from. And it sounds like it's really a largely unprocessed diet. So if you come to it from differing dogmatic principles about nutrition, whether it's low carb or keto or carnivore or plant-based, that there's a way to adapt it for your lifestyle. Yes. Please let listeners know how can they connect with you? How can they purchase your book? Obviously, it's going to be part of my must reads for 2022. It's a great book, and it really there's so much about it. It's not just focused on the science. There's a lot of anthropology and evolutionary information that's in there. Like, you can completely nerd out. And for full disclosure, I had over 20 pages of notes. I was trying very hard to focus on the big concepts. I could have spoken to you for hours, but let our listeners know how to connect with you outside of the podcast.
Well, thank you so much for the interviewing me. And you can reach me through drrichardjohnson.com. That's my website. That's the easiest way. I do have Instagram and Twitter. It's Dr. Richard J. Johnson, Instagram. But I'm not great at using social media, but I'm trying to learn more. You remember I'm a scientist. Remember that I'm a scientist. Anyway, yeah, and then, it's available through all the bookstores and websites. But yeah, drrichardjohnson.com is a great way to reach out to me.
Hey, if you like this video, you guys are going to love this video, and I'll see you there.
We make almost all of our fat cells during childhood and puberty. And then once we finish puberty, we're done. That number of fat cells, in most people, there are some people who are an exception to this, and that's about 15% of people who are in the obese category. But most people reach a limit, and that's their fat cell number essentially for adulthood.